Next block is enable contraception. It is very simple. If you want to enable, you select 1. If you want to disable, you select 0. This is it. Practically very like mechanisms that you had with modules when you worked with modules of the device. Next block is receive CAN message. How it works. So device obtain filtered or not filtered information from the CAN bus. It save obtained identifier to ID variable. So actually you can specify here any name of the variable you need. I called it ID with small letters. After that, since CAN bus data typically has 4 bytes of information, and in our Galileosky devices variables are only 4 bytes. This information is separated to 2 variables. So first part, bytes from 1 to 4, will be saved to data 1, and other 4 bytes of the message, of the coming message, will be saved to variable data 2 or whatever name you specify here. After that, length of data that arrived, length will be saved to len variable. So sometimes it is not obligatory that you get 8 bytes. You may get less, for example, even 1. And this block, it is condition. So if information was received and successfully saved to these variables, you will get true, and device will go through true arrow. And if there is no data, device will go through false block, and typically it's better to put delay and come back to receiving block, so in order to check all the time what data are coming. About sending CAN message. It is practically very similar to receiving. You specify identifier here. You specify 29 or 11-bit identifier. You write from some particular variable what length will your message have. Save data from variables data 1 and data 2 and select interface. Pretty the same. Please don't forget that by sending some not appropriate information, you can kill the vehicle, and we don't hold responsibility for this, so it's only your responsibility when you do such things. Next block, CAN message parsing. Actually, this 8-byte of arrived message, which are separated to 2 variables, they are saved to part 1, part 2. We typically don't need all this part. We need some particular bits or some half of the byte or something like it, or even several bytes. We need to extract this information, and by this block you can select whatever you need. So it is much more flexible than in CAN scanner, because you can select like 2 bits, and it is not available in CAN scanner. And after that, you save this particular value to some another variable. For example, this would be called like vehicle speed, and this is brake pedal, for example, something like it. Please pay your attention to one important moment. We have here captions for bytes, so 1, 2, 3, 4, 5, 6, 7, 8, and we have here captions for bits. And sometimes it is different how we represented this and how it is presented in documentation. For example, numeration of bytes, it is equal here, but bits are written from right to left, not from left to right. That's why when you need to extract some particular bit, please remember that if it is located like for 2 position here, it will be byte 6, it will be this exact variable, not like this. Please be attentive with this small detail. Also, by default, we have little endian variables. If you need big endian, please you can check it here, and device will automatically reverse this thing. As for general approach that we have for work with CAN data in our easy logic algorithm. First of all, we initialize CAN bus, specify the speed forbid sending to CAN messages if we don't need them. I remember that initialization should be only one. After that, we add in filter that will allow us here to extract messages with such center, so FEE9, and we enable CAN message reception. After that, we check if some new data came to us. If no, we just wait a very small amount of milliseconds, so please be attentive. CAN bus data, they are coming rather often, so such kind of small delays is needed. If no data, we are waiting. If there are some data, we save ID, identifier of the message, to this first variable, data to these two variables, and length of obtained message to the len variable. After that, we can use parse block, put to some another variables, data taken from data 1 and data 2, and for example, after that, do something else with these variables, save to some user tags, etc., etc. Anything you actually need. This is general idea that we have for our work with CAN bus. So convenience of it is here processing, so extracting some particular bits, and later in implementation of some additional logic using obtained values. So for example, you can write to this variable and here create different chain and process obtained information there somehow, depending on your needs, depending on your project and task. What also can we meet? What also can we see? Two identifiers. What does it mean? For example, we need to get information not just from one identifier, but from two particular one or even more. How should we deal with this? So initialization block is still one, but we add additional filtering block with typically the same mask, but it will extract byte 2 and 3 from the center, and using this we will filter data for two PGNs. After that, when we received message, our identifier was already filtered. Because we applied filter, it is necessary to just bit shift this to the right for 8 variables, because last byte is 0, so we need to move in order to don't have this tail and don't have wrong value in the very beginning. So zeros in the beginning means nothing. That's why here you can see bit shift for 8. After that, as far as I remember, there is no need in this check, but just in case, we throw away a front. No, sorry, I misinformed you. So we filter here just general data flow, but here in identifier we have exact value. Yeah, and that's why we should bit shift anyway and filter like apply such kind of mask FFFF in order to get only 2 last bytes. Or you can apply the same mask like here and after that make bit shift. So up to you. Then in ID, we will have exact PGN, and if we have such kind of PGN, then we do this kind of actions. If different kind of actions. So depending on value, we can create different processing. It is very, very important in real life projects.